Yep.
Okay. Oh, there it is.
Good morning, everyone. We're here on this early morning to watch the launch of NASA's or several NASA missions, including the Interstellar Mapping and Acceleration Probe, or IMAP. And there are two other missions, which we'll be talking about as time goes on. The launch is scheduled for less than an hour from now, and I am here with David Allion, who is in California, and
Good morning.
Greg Diesel-Walk, who is on site at Kennedy Space Center.
Good morning.
So here we are, and we are about to, let's see, we are streaming from Spaceflight Now, and I am just going to turn that sound back on and see what we've got here.
You may also, from time to time, hear what you just might have heard over the loudspeaker coming from the vehicle assembly building adjacent to the press site here. Of course, as NASA continues towards the planned launch of Artemis 2 no earlier than February 5th, things are moving along quite steadily in preparation for that.
Well, the
NASA's
conditions
just about a
look
week
good.
away from taking the Orion spacecraft, now with the launch escape system, which that work is set to finish out towards the end of this week. And next week, it'll be transferred over to the vehicle assembly building ahead of stacking and integration with the rest of the SLS rocket. And we'll have the full stack of the Artemis 2 launch vehicle and spacecraft.
And we have two rockets on the pads here right now. We have an Atlas
All
that's
that being
scheduled
said,
to
you may
launch.
hear some announcements over the loudspeaker as we go throughout the broadcast. We have no control over that. It just happens periodically. So if you hear a little bit of a mumbled additional voice beyond my own, that's clearly not a call out related to this mission.
So let me talk a little to my co-hosts here. Guys, can you see the mute button on the live stream?
The mute button on the live stream.
I see a microphone button.
No, we can't see the live stream. Only you can do that. You're sharing it. Oh, wait, maybe I do see it.
Below the stage, do you see that?
I do see it. Yeah, I see it there.
Okay,
Got it.
so if you're going to talk, hit that mute button before you talk, okay?
Can you tell me where
Sure.
it is again?
So Greg, see
phone.
below the stage here where we're appearing? And underneath there, you'll see the stream and a little box. Oh, let's move this conversation to the private chat. Dave, you see the private chat in the right menu bar? Okay,
Yes, I
we're
do.
going to go back to the stream.
And at the same time, liquid oxygen will begin flowing on board the rocket's first stage. T-minus 30 minutes is when SpaceX starts to load cryogenic helium onto the pressure vessels for the Falcon 9's first stage. Same will be true regarding the second stage a couple minutes after that point. That helium is important because it's used to pressurize the main propellant tanks during flight. T-minus 23 minutes is when second stage RP1 tanking is complete. And about T-minus 20 minutes and 50 seconds is when the strong back chill down process gets underway. This is when SpaceX is thermally conditioning the feed lines there at the pad prior to
Yeah, we lost
I think we lost the audio.
I just wanted to add him as honorary member of this poll, starting with CFA.
Thank you, NLM. CFA is go.
NASA CE.
NASA CE is go.
SMA. SMA is go. SMD.
This is SMD. IMAP is go.
NASA MIM.
NASA MIM is go.
LSP.
LSP is go.
NASA team is ready for propellant load and launch.
Okay, so it looks like we are go for launch this morning with NASA's IMAP mission and 2 others. Greg, what's the weather look like there?
We have some distant lightning down to the south of us, but it's not in the trajectory of the rocket. Right now, it's about 80 degrees, very calm winds, clear over the pad. We have some beautiful crepuscular rays before sunrise here. So it's a great morning to be at NASA Kennedy Space Center for EarthSky.
And how many people are there, Greg? Photographers like you watching the launch?
So it's actually as a light morning, typically a lot of TV crews. This mission is important for science and the space weather study of the sun. So that's why we're here. And there's others here that have the same values. NASA has a stage set up and broadcasting. Otherwise, I did not have to fight too hard for space. Also, you have to get up at 3 in the morning for a launch like this, so that discourages some.
Going
of
the
media as
extra
well.
mile, Greg. We love that.
It's a great opportunity.
Yeah, I'm sure it's beautiful there. Just beautiful.
It looks
Yeah, this
very
is a beautiful
nice.
morning.
So this mission, the IMAP mission, the launch will take place no earlier than 6:30 a.m. Central Daylight Time, and that is about 40 minutes from now, so no earlier than that. And they're going up on a Falcon 9. The booster will return and land on an automated recovery barge in the Atlantic Ocean. I'm not sure which one.
I believe it's
Yeah.
just read the instructions, and this is an instantaneous launch. It either goes at 7:30 Eastern Daylight Time, or it scrubs to tomorrow.
Oh, that's good to know. That's good to know. Okay. So what's going on here with this spacecraft, with IMAP, which is the primary mission that's being launched here, is that it's going to study the solar wind. So the solar wind is a continuous stream of charged particles from the sun. It's mostly protons and electrons, and it's flowing outward from the sun at all times. So EarthSky has a daily sun update, and we talk every day about what that solar wind is doing, because there are many people on Earth who want to watch auroras, and the direction of the solar wind and the speed of the solar wind has a lot to do with whether or not you're going to be seeing auroras that night.
Something certainly on my bucket list.
Let's go
You
back
sh-
to
I
the
recommend
let's go back to the stream for a second.
The SpaceX launch director, following the words that we heard from NASA LSP. SpaceX also ready to start the prop load process, which again, as we were just discussing, will start at the T-minus 35-minute mark in the count. So given the readiness of NASA and the readiness of SpaceX, things are moving along quite well this morning, as we've got now 39 minutes remaining on the clock. Continuing on our conversation about the countdown, once the chill down process has begun, we'll see that visually manifest as the so-called big vent that'll happen here at pad 39A at about T-minus 20 minutes and 30 seconds. That venting will last roughly 4 minutes in duration. tapering off and setting the stage for second stage LOX load to begin at the 16-minute mark. Moving right along, T-minus 7 minutes is when the chill down of the 9 Merlin engines at the base Falcon first stage booster gets underway. SpaceX will flow a small amount of liquid oxygen through the plumbing and turbo pumps, helping to protect those engines from the risk of thermal shock and damage during startup. About 6 minutes ahead of liftoff, the first stage kerosene tank should be full. Then at T-minus 4.5 minutes, we'll see the retraction of the strong back. First, the clamp arms just beneath the payload fairings will open up, and then the transporter erector, otherwise referred to as the strong back, will recline a few degrees away from the Falcon 9 rocket, and it will stay in that position until liftoff. Then at that point, it'll pull back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9 rocket. 3 minutes before takeoff, the first stage liquid oxygen tank should be full. 2 minutes out, same will be true on the second stage. At that point, the Falcon 9 will be fully loaded with 1 million pounds of propellant. In the final 60 seconds, as we hear the call that the Falcon 9 is in startup, what that means is that the control of the countdown will be handed over from the ground sequencer to the Falcon 9's onboard flight computers. Simultaneously, the propellant tanks are brought up to flight pressure. SpaceX launch director.
This is the launch director with abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
And we've got an image of what looks like Darth Vader standing in a
Good words from
swamp.
Mission Control. The standard overview, just letting everyone know what the procedure would be for an abort scenario. That being said, things are progressing quite well, as we've been hearing throughout the course of the countdown up to this point. We're just about a minute away from the start of tanking. So we'll go ahead and finish up our countdown timeline. Once the SpaceX launch director gives their go-ahead for liftoff, then the final pre-launch item will be the engine ignition command being issued at T-minus 3 seconds. And if everything has continued to progress well up to this point, then at T0, we'll see the liftoff of this Falcon 9 rocket with these key NASA and NOAA payloads on board. SpaceX, NASA, NOAA targeting a liftoff of this mission at 7:30 a.m. Eastern, 11:30 UTC for those around the world.
Okay, so we've got 35 minutes until the launch. And I just want to continue with what IMAP is. It's going to investigate the solar wind. It's carrying 10 instruments. It's a simple spin stabilized spacecraft. And we hear that engineers are going to have to make daily maneuvers to keep the spin axis and the top deck with its solar arrays pointed in the direction of the incoming solar wind. So, Dave, you know about where this mission is going to be placed, right?
I do know about that. It's going to go to the Lagrange point 1 between the Earth and the Sun. That's L1. And that's a spot in space where the gravitational attraction of the two bodies sort of cancels each other out. So it's very easy to keep station in space at a Lagrange point. So that's where it's heading. It's setting sunward. That means it has to kill off all of its Earth side momentum before it can head inward.
Yes, and so that's such a cool thing that that scientists figured out that there are these Lagrange points in the in various systems, the Earth-Sun system or the Earth-Moon system, and those are places that are gravitationally easier to stay in than elsewhere in those systems.
They're in equilibrium. So the pull of the sun and the pull of the Earth in this case are very, very similar. So it doesn't tug it out of its place in space. Still has to keep station though. They still do need to keep it there. There is some drift. It's not perfect.
Right. Right. And as I just said, they have to keep the spacecraft oriented toward the sun so that its detectors can be facing straight into the solar wind.
Right. So that's going to be a very busy mission at Mission Control. They'll be on that one every day. Although I assume they're going to have some kind of computer assist on that. I
Oh,
don't think they'll be flying it by hand.
no doubt. No doubt.
No doubt about it.
Let's just briefly mention the other two missions that are going up here. In addition to IMAP, there is the Space Weather Follow-on Lagrange 1 mission that will also monitor space weather with real-time measurements. And there is the third mission going up today is the Carruthers Geocorona Observatory, and it's going to capture views of what's called Earth's geocorona, and that's the outer part of the Earth's atmosphere.
Yeah, it's going to be monitoring. We're going to go back. Okay. Well, it's just going to be monitoring the interaction of hydrogen atoms with the solar wind at the edge of Earth's furthest atmosphere. So about halfway to the moon.
Okay, let's go back to the stream.
Let's go.
Very newly heading on their way to Lagrange Point 1, in addition to all the other NASA missions currently underway, including the run-up to the Artemis 2 mission. We spoke with the Associate Administrator, Nikki Fox, with the Science Mission Directorate yesterday to learn more about what will happen to NASA science in the event of a government shutdown. Should that happen? Here's NASA's Nikki Fox.
Cease the work, the government is shut down. And so we will focus on making sure that we maintain life and we maintain property. So of course, any astronauts on the ISS, we're taking care of them. Our missions in space that are operating, we're very much taking care of them. For IMAP and the missions launching, which we're all excited to talk about, then we will be putting a lot of effort on maintaining those. Any other work that does not pertain to life or property, then we will stand down until the government tells us to come back, whether it's under a continuing resolution or whether it's under an appropriation. At that point, we'll know the level that we'll be operating. So that we'll either be given guidance in the event of CR, or we'll be given an appropriation. So we look forward to getting that guidance and then continuing to do the great science that we do at NASA Science.
Again, do you want to just preface or remind folks that a government shutdown is not a certainty, but given that it is a high probability, T-minus 30 minutes, want to mark that. We, of course, wanted to know for our own benefit, but also to, of course, share with you all what would happen with key NASA science missions as best we're able to get an answer to that at this point in time. Obviously, things are still in flux, and we'll continue monitoring the situation and let you know if there is a government shutdown, the missions that are impacted, that are in flow at this juncture. Less than 30 minutes to go before liftoff of this Falcon 9 rocket. You can see some of that vapor trailing off from the base of the booster. Good visual indicator that, as we were, of course, made aware of through those callouts, that tanking is underway. Right now, SpaceX is also loading cryogenic helium onto the pressure vessels for the Falcon 9's first stage. It will do the same on the second stage coming up here in the next few minutes.
So that was interesting what they had to say about the government shutdown, that during a shutdown, they'll be maintaining, of course, life and also property. So presumably there will be NASA engineers Even during a shutdown, the NASA engineers will continue to maintain the various space missions, of which there are many out in the solar system right now. And the sun, in particular, has a lot of spacecraft aimed at it because the sun, of course, is, our local star. It does sometimes some unpredictable things, and those things can affect uh, conditions on Earth. Everyone is well aware at this point of the Carrington event that happened in, do you know the date, Dave, of the Carrington event? 1859, 1849?
You know what? I don't off the top of my head.
It was in the
I don't.
1800s.
It was in the late 1800s.
Why don't you know about that? Why don't you tell us about that?
Well, there was a large solar flare, X-class, obviously more powerful than anything we've seen recently, and it was so energetic that when the particle stream reached the Earth and came through the magnetosphere, it started creating sparks in places like telegraph offices. The wires were picking up the energy. We were seeing sparks coming off of just fences, like, barbed wire fence lines, things like that. So if we were to see something like that these days, it could have a pretty big effect, but not disastrous entirely on our electronics. At least that's my understanding.
Yes, and also our electric grid. So when EarthSky first started live streaming, which was, oh gosh, I don't know, a year or so ago now.
A little over a year ago, yeah.
Yeah, one of the first people that I interviewed was an electrical engineer, and we talked about what would happen if a solar storm the size of the Carrington event hit Earth today. And he told me that over the past decades, since people have become aware that there could be another Carrington event, that scientists and engineers have met regularly to talk about how to protect our electric grids from that. And so one thing that they've done is they've created more modular components so that if a big solar storm happens and it affects an electric grid here on Earth, that there can be a modular piece that can just be lifted out and more easily replaced. So it wouldn't be that it would instantaneously be fixed. People might have some inconveniences for a while, but it wouldn't be a civilization disaster like it might have been if they had not prepared for it.
Right.
So it wouldn't be months of outages. It might be more like a week or a couple of weeks of no electricity.
We had an event
we
like
could
that.
survive that. We're all surviving that now. There's power outages of that magnitude now. We had one here in Texas that lasted, the whole state had no power for 4 days.
Well, we have a sending station here. There's a hydroelectric dam not far away, and one of those units went out, and it took about a week for them to get the replacement unit in, but they were able to just pull it out, put the new one in. It was quite a spectacular show. There were huge arcs flying off of the station. It was incredible, but inconvenient to say the least. So let's hope there's no Carrington level events in our near future.
Yes. And, I know. Yeah, so true. So nice to have electricity.
Yeah.
But that's what
I
this
wouldn't want to go
mission is
living in-
about. This mission is a pure science mission. In fact, it's the last pure science mission that's going up in 2025, but it's also there to study the solar wind, which is part of what we need to understand in order to keep ourselves safe from solar storms.
It is. And one of the missions is, you mentioned the geodesic, that's GLIDE. And I'm not sure what that's going to tell us about solar storms. So that one might be something we need to get somebody on the air to talk over with us.
That's a good idea. We should do that.
Yeah. We can get an expert in here to talk about what these missions are actually going to do for us in terms of safety. in terms of predicting these solar storms, because these things can have a great effect on astronauts in orbit, or if we decide to go to the moon or Mars. So we need to know these things. These are really important numbers for us for safety reasons. So
We are going to the moon.
we are. We heard the call out earlier. They were talking about the stacking up of Artemis 2. They're going to send people around the moon and back again.
That's right. And I think that's going up in February. Let's go back to the stream real quick.
Let's do that. Let's see
NASA
what
and
they have
its
to say.
partners on this mission are planning to get some good science data for the foreseeable future with the Carruthers Geocorona Observatory. Just one of the 3 payloads that's flying today, heading out to L1. Currently T-minus 22 minutes, 44 seconds and counting. In the next couple of minutes, we'll see the start of the so-called big vent as SpaceX thermally conditions the feed lines there at the pad prior to second stage LOX load.
Okay. Looks like we lost Greg. I think he'll be back in a second. So Greg Diesel-Walk has been here with us. He is at Kennedy Space Center, and he's a photographer. He's a great photographer, and you will often see his pictures at earthsky.org. And he's going to be photographing the launch this morning. So we just lost him. I don't know where he is, but he will be joining us again soon, I'm sure. I'm Deborah Bird, and I'm here with Dave Adalian to talk about the IMAP and 2 other missions being launched this morning. And do we have a clock? I think they just said it's about 20 minutes from now.
It's up there underneath our EarthSky logo, so we can't see it, but I happen to have it right here in my hand.
Can we get rid of that logo, Dave? Let's try to get rid of it so we can see that.
I don't know that we can in the middle, but of the chat, but I can sure take a look.
Oops.
That's not it.
That didn't work.
I can tell you, however, that we have 20 minutes and 37 seconds until launch.
Okay. I'm kind of dangerous clicking these buttons over here.
Well, you know, that's the magic of live TV, isn't it? What happens if I push this? Oh, no.
Right.
I'm an inveterate button pusher. I get in trouble all the time. What's this do? What's in this drawer? Hey, let me look in here. No, don't do that. You're going to find out things you don't want to know. So there you can see the oxygen, right? The oxygen bleeding off there. They are doing the propellant load. That's what that is. That's underway now.
Let's go to the stream.
Sure. Well, that should be the liquid oxygen chill down. Should be happening now. They've been loading the propellant for about 15 minutes.
And it looks like we're at T-minus just under 19 minutes.
Time now, T-minus 18 minutes, 5 seconds and counting.
There
With
you
a
go.
couple more minutes remaining on this big event, want to thank the more than 2,000 of you who are watching along with us live today. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream, allowing some more folks to find their way into this live launch coverage.
Okay, so that was, I believe that was the announcer from Spaceflight Now. So sharing Spaceflight Now's page, and we are EarthSky. I'm Deborah Bird. I'm here with David Dalian, and
Folks.
we are watching the launch of NASA's IMAP mission. IMAP stands for Interstellar Mapping and Acceleration Probe, and its job is going to be studying interactions between the solar wind and the local interstellar medium. And one of the things that IMAP is going to do is find the boundary of the heliosphere. So our entire solar system is moving along through the galaxy inside a big bubble, the sphere of the sun's influence, aka the heliosphere. So part of IMAP's job is going to be to find the boundary of that heliosphere.
And today, when the rocket takes off, it is going, the mission that it's carrying is going to the first Lagrange point between the Earth and the Sun. But when it does that, so the rocket's going to go basically due east. It's going to head out over the Sargasso Sea, the calm, still Sargasso Sea, north of the Bahamas. And about halfway across the North Atlantic Ocean, it'll leave the atmosphere and head into orbit.
And then the rocket's coming back, right?
The booster will come back, and yeah, just the booster. The second stage will proceed to orbit. We won't be seeing it again. I don't know if they're doing a fairing recovery. Usually SpaceX will try to recover the payload fairings that cover the top of this craft where the actual science package is. And so they might be
Hang on a
after
second,
those.
Dave. Let's go back to the stream for a sec.
With its Falcon 9 rocket, NASA is the main agency overseeing the IMAP spacecraft. Also, some of the other two major partners are the Johns Hopkins University Applied Physics Lab and BAE, who are behind the instruments and the construction development of the spacecraft itself. You can see IMAP there is the little icon at the bottom of the screen next to the name IMAP. The other two little green spacecraft, those are the SWIFO L1, which is the one with the boom extended from it on the right. And then to the left of that is the Carruthers Geocorona Observatory. Giving you a look at not just the sort of cartoon version of them, but the spacecraft as we were able to see them in the clean room. This next series of photos come to us from our photographer, John Pisani, who was thankfully able to join and going into his first opportunity inside a clean room, getting to see these spacecraft up close. We were also wearing those protective garments that you're seeing these technicians wearing in this photo. This is a picture of the IMAP spacecraft itself. IMAP stands for Interstellar Mapping and Acceleration Probe. It's going to be doing a comprehensive mapping of the heliosphere and learning more about the dynamics between the solar winds that provide the pressure within the heliosphere extending from the sun, pushing against the cosmic radiation that comes from beyond the outer boundary known as the heliopause. And so seeing the interplay between those, the particles that are emanated from the sun and the energetic neutral ions that come back from the heliopause that'll be heading into some of the instrumentation from the IMAP spacecraft. And that'll give us a much better understanding of both the size and the dexterity of the heliosphere itself. Actually, let's go ahead. We're seeing some images now inside the Johns Hopkins Mission Control Center, calling it audible. If we can bring that in, you can see now inside where this team will be operating the spacecraft. According to NASA, they should be getting control or a signal back from the vehicle at about L plus 1 hour and 33 minutes post liftoff. That's a rough estimation of when they should be getting signal from this particular vehicle. IMAP will be the first of the 3 spacecraft to be jettisoned from the Falcon 9's second stage once the rocket takes flight. IMAP deployment is coming up at about T plus 1 hour, 23 minutes and 51 seconds. It'll be followed roughly 7 minutes later by the deployment of the Space Weather Follow-on Lagrange 1 or SWIFO L1 spacecraft. That's from NOAA. Let's go ahead and show you the next vehicle. This is the Carruthers Geocorona Observatory. This will be the last spacecraft that will be deployed at T plus 1 hour, 36 minutes and 46 seconds post liftoff. Here's an image of the SWIFO L1. It has a suite of 6 instruments, and as compared to Carruthers and the IMAP instrument, which will be gathering more research data in order to better inform how we know and understand and can respond to various elements of space weather. SWIFO L1 from NOAA is the action point spacecraft. So its suite of instruments are designed to monitor the sun's activities and be able to send that information back to decision makers here on the ground in order to better protect property and infrastructure from the impacts of solar weather, in particular coronal mass ejection that could have negative consequences for things in orbit like satellites and astronaut health, as well as things that affect us directly here on the planet who are not in space and are not satellites, but obviously, you know, we are all very much connected to our space ecosystem through the GPS constellation and other key satellites that affect our day-to-day lives. But strong solar storm can also negatively impact the power grids depending on its severity, its duration. Airlines also rely on communications that could be impacted by a strong solar storm. So the tools
are on internal power.
That are now on internal power, as you just heard, will be brought to bear in protecting the Earth from impacts of solar storms. NOAA is also sending a coronagraph on board a future mission from the European Space Agency that is set to head out to Lagrange point 5 as opposed to the spacecraft at L1. And the benefit of that is at the L5 point, that spacecraft will be able to see things like sunspots on the sun as it's rotating towards the Earth. So we'll get a little bit of a heads up on some of those events before they start potentially having a direct impact on us here on our little blue marble.
Okay, so we have Greg Dieselwald back with us. Greg is at Kennedy Space Center. Greg, what's going on there?
So had some internet issues. We're still kind of out in the middle of nowhere here at Cape Canaveral, but we're at just over 8 minutes and counting. Weather is beautiful. All systems are go. It's a great morning to be here at Kennedy Space Center. You see the countdown clock behind me right at 8 minutes. Cameras are ready to go.
Is there like a thrill that goes through the crowd there as it gets closer?
Yeah, sometimes you hear cheers and clapping as we get through different call outs. Yeah, there's definitely a level of excitement. You get past the 2-minute mark and you're pretty much guaranteed that it's gonna go.
Very cool.
Yeah,
I
the
tried to
onboard
watch
system.
a couple of Starship launches from South Padre Island, and that neither one of the times that I went did Starship go up, but I'm still trying to get down there to do that.
I recommend catching a rocket launch. It is unlike any experience you will find anywhere else. It's a total body experience. First of all, there's so much power coming out of those engines that it hits you in a wave of pressure about the same time the sound arrives, and it's overwhelming. It's the sensation is the voice of God is coming down upon you. It's just so loud. It's loud beyond loud. It's an incredible thing. I definitely recommend that experience. I live over here by Vandenberg. Oh,
Let's go back to the stream, Dave.
In regard
Yes, ma'am.
to first stage RP1 loading being complete, that should happen right about T-minus 6 minutes.
right.
And we want to say again that this live stream is coming from Spaceflight Now, and they just do a wonderful job of presenting these things. So thank you, Spaceflight Now.
Yes.
Loading. Coming up next, the next call out we should hear should be regarding the tanks pressurizing for the start of the reclining of the strongback. We'll hear that call a little bit past the 5-minute mark.
Yeah, you're good, right?
I don't know about you guys, but I'm starting to get a little bit excited here.
Getting close. The sun is up. It's bright here to the east of the rocket. Some photographers are going out for a solar transit. Those are always cool, but I would like to be here at the trusted and true press site.
Just beneath the payload fairings to open up, and then the strong back will recline a few degrees away from the Falcon 9 rocket.
Strong back retract has started.
It's getting exciting now.
NLM, this is LD on countdown 1 with a status check.
LD, this is NLM. NASA's go for launch.
Right.
And a good go for launch call from NASA. Launch Services Program, or LSP, managed here at the Kennedy Space Center. With the NASA side of the coin good to go, we're now coming up to the final bits of the fueling process. In roughly 30 seconds, we should hear a call that first stage LOX load is complete. Same will be true on the second stage at about the 2-minute marker.
And I'm showing 3 minutes right now.
That's correct.
Stage 1 LOX load is complete.
So we've got people from Arizona. We've got people from Florida watching. We've
And a
got
good fueling call there. Less than 3 minutes on the clock.
Scotland is well represented today, and South Africa.
Amazing.
Taking a quick peek at our chat. Want to thank the more than 5,100 of you who are joining with us live. If you haven't already, certainly appreciate it if you could hit that like button, share the stream so more folks can find their way in at these final few minutes of the count. Should be a very spectacular sunrise launch in just about 2 minutes. Also want to
2
quickly
minutes.
thank our moderator, Aussie Space Girl, for joining us from down in Australia. Thanks to Ray Rose for a $2 Australian super chat.
And Michigan is with us.
Stage 2 LOX load is complete.
With that call, the Falcon 9 rocket is now fully loaded with 1 million pounds of propellant.
Okay, here
As
we
we come
go.
up to the 1 minute mark in the count, you're seeing now the ground gas closeouts. SpaceX releases
really
the remaining liquid oxygen from the feed lines there at the pad.
really see the venting there clearly, which is a great sign.
Ground gas closeouts.
There's that call confirming that. Want to quickly thank as well K2 Hat for a $5 super chat. Thank you, K2, who says, "Good morning from Miko. Thanks for the coverage. As always, great job." Appreciate
1
the
minute.
kind words. Appreciate you being here as we're now approaching the final minute of the count, and our attention will be squarely focused on the rocket as we're looking for the start of the automated sequence of the Falcon 9.
Falcon 9 is in startup.
And with that good call, we are now just awaiting the SpaceX launch director to give their call that they are, in fact, as well, go for launch. That's coming in the next few seconds.
Hold your breath. Cross your
Launch
fingers.
director is go for
30
launch.
seconds.
And a good confirmation that things are progressing as expected. That go for launch call means we are now just a little more than 30 seconds away from the flight of this Falcon 9 rocket and these key heliophysics missions heading up on their way to Lagrange point 1, a million miles from Earth. 20 seconds and counting.
Greg's a little bit ahead, so we might see his lift off.
Here we
15
go.
seconds.
Lift off.
And here we go in 10, 9, 8,
Lift off.
7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff. Liftoff with the Falcon 9 rocket on the IMAP rideshare, getting ready to explore the sun and the heliosphere and all it contains.
Rock and roll time.
And a beautiful solar transit. Well done to our Michael King for that shot.
Beautiful, guys. Beautiful.
Everything progressing nominally with the Falcon 9 rocket as we're coming up on a minute into the count. The rocket is approaching max Q, the point of greatest aerodynamic pressure on the vehicle. It'll throttle back on its main engines as it's now passing the speed of sound. Coming up on max Q now.
That's Greg's camera you're
Passing
hearing in
through
the
max
background.
Q, the rocket will throttle back up on the 9 Merlin engines at the base of the booster. About a minute and a half into this mission. Coming up next will be the thermal conditioning of the Merlin vacuum engine on the rocket's second stage. Confirmation of MVAC chill. We're coming up to a few events in fairly rapid succession.
So it's headed east now.
We'll see
You
first
it
stage main
tipping
engine
there?
cutoff or MECO at about T plus 2 minutes and 29 seconds. That'll be followed by stage separation at 2 minutes 32 seconds. And then the Merlin vacuum engine on the second stage will ignite for the start of its first burn at about T plus 2 minutes and 40 seconds. The payload fairings will jettison a little more than 3 minutes into this flight.
So no word if they're going to recover those fairings. They usually
About 10
try.
seconds to MECO.
And you can really see that it's going east now. It is not going up. It's going east.
MECO. Stage separation. And second stage engine start.
Beautiful.
Looks clean.
Really nice visuals. Good job by the tracking team.
All right,
A little more than 3 minutes into the mission. We're coming up on fairing separation momentarily.
took my headphones off to get away from the clicking distraction, but we're able to track it all the way up into the clouds and see the fairing separation and the booster separation.
Gorgeous.
Yeah, good
And there you
launch.
can see
Clean.
the sky.
And the fairings have been deployed. Good
You can
view
see them there
briefly
falling.
of
There they are.
the 3 spacecraft. As you can see, one of those fairing halves making its way back down to the waters of the Atlantic Ocean. It'll splash down under the support of steerable parachutes once it's back through the atmosphere.
Hello, Michigan. Hello, Minnesota.
So far, a very by-the-books flight as we're coming up on 4 minutes into the mission. Coming up next will be the start of the first stage entry burn, which will begin at roughly T plus 6 minutes and 37 seconds. That'll call upon 3 out of the 9 Merlin engines at the base of the booster to begin to slow that part of the vehicle down. Burn should wrap up
cool.
just a little past T plus 7 minutes into flight.
Cool thing here at the Space Center, the clock also goes into the positive of launch as well. So we're 4 minutes and 45 seconds into the launch.
Coming up to 5 minutes in the flight. We still have a bead on the Falcon booster, but it is behind quite a bit of clouds from our camera's vantage points. So not super confident that we'll get the start of the entry burn with our tracking cameras, but we are still seeing those puffs of the cold gas thrusters on the booster, which help it adjust its attitude or positioning as it orients itself towards the drone ship called Just Read the Instructions, waiting for it out in the waters of the Atlantic Ocean. Of course, if we are able to catch that entry burn, we'll bring that to you. It's set to begin now in less than 1 minute. Coming up on the start of that entry burn here in less than 10 seconds.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
Good calls there. The second one was regarding the FTS, or the flight termination system of the booster. Safety mechanism no longer needed at this point in the mission.
Stage 1 entry burn shutdown.
With the conclusion of that entry burn, next up will actually be the conclusion
Stage 2 is in terminal guidance.
the burn on the second stage, which is what that call out was just regarding. Stage 2 entering terminal guidance is the call that comes just prior to the upper stage wrapping up the burn that it's in.
Stage 2 FTS is saved.
Good call there. Engine cutoff should happen momentarily.
Stage 1 transonic.
MVAC shutdown.
Some good call outs there. The first stage booster now traveling below the speed of sound, and the upper stage now entering into the start of its
Nominal
coast
park
phase.
orbit.
And a good parking orbit to boot. Coming up on the start of the landing burn here in the next few seconds.
Stage 1 landing burn.
Is set to be the second landing for this particular Falcon 9 first stage, B1096.
Landing leg deploy. Stage 1 landing confirmed.
Amazing.
And a good touchdown
one.
for this booster, having now made its second trip to space and back, following its launch of the Kuiper Falcon 1 mission earlier in the summer.
Always amazing to see that.
Amazing.
And a really nice view of the spacecraft that are on board this Falcon 9 rocket. Now, a little more than 9 minutes into the mission. At this point, the rocket, or the upper stage of the rocket, will remain in a coast phase until T plus 1 hour, 12 minutes, and 28 seconds. There will be a roughly 1 minute burn to help put the rocket on the correct trajectory ahead of the deployment sequence beginning. And that will start at T plus 1 hour, 23 minutes, and 51 seconds post liftoff. Again, we will start by seeing the deployment of the IMAP spacecraft. That'll be followed by the deployment of NOAA's SWIFO L1, and then finally wrapping things up with the jettisoning of the Carruthers Geocorona Observatory at T plus 1 hour and 36 minutes into the mission.
I'm just going to mute that for a second because that's it. We've got it into its parking orbit. It's going to sit there and we're not going to see any action at all for about an hour until they insert it into its solar orbit.
Yeah, it's always great to see. There was that 1 day delay, but it's always great to see everything go smooth, from start to finish. And excited to see these science satellites get to their destination and help us better understand solar winds and space weather.
It's going to sit here and wait for that engine to light up.
Time now T plus 11 minutes, 37 seconds and counting. It has been a smooth and nominal flight of this Falcon 9 rocket so far. As you can see, the upper stage is just about over the middle of the Atlantic Ocean, heading towards the west tip of the continent of Africa. Going to do something a little unusual for one of our broadcasts. I'm actually going to be stepping away from the mic, and we're going to do our own handover here at Spaceflight Now, and I'll be passing you off to the very good hands of our editor, Stephen Young. So I'll bring in Stephen now. Stephen, how are you this morning?
I'm doing good. How are you, Will?
Good. It is still dark here at Houston, a few miles away from the Johnson Space Center. The reason that I'm here, of course, and not in Florida with the rest of our team is today is the second of a 2-day very thorough debrief on the upcoming Artemis 2 mission. Today's the day where we're going to be hearing directly from the astronauts themselves. So looking forward to hearing that panel, and then we'll also be sitting down one-on-one with astronauts Victor Glover, who is the NASA astronaut in the pilot's position, and Christina Cook, who will be one of the mission specialists flying aboard the Artemis 2 mission next year.
It sounds like you've already had a very packed visit to the Johnson Space Center. What are you looking forward to hearing today from the crew?
Well, so yesterday, just to give a quick snap recap of what we learned and saw, for those of you who were able to follow on our social media, we got a really robust and as detailed as we've gotten overview of the mission, the milestones, the science that'll be happening from the really the point we're at right now, the preparations of the SLS rocket and Orion spacecraft currently in its final flow before final stacking at the VAB. That's all going well. Orion should be integrated sometime next week onto the top of the stack. And then we got a little bit of an overview of what the rest of this year is going to look like with the rocket on the mobile launcher that'll head out to the pad. Unlike last time with the Artemis 1 mission back in 2022, the plan is for the rocket to roll out once. And once it's at the pad, it'll go through its final checkouts, communications between the rocket and the mobile launcher, the ground infrastructure out of the pad. The crew, because this is the first crewed mission, will also be doing their first walk down with the rocket at Launch Complex 39B and checking out some of the systems like the emergency egress system, which wasn't a factor for Artemis 1 since there was no crew to egress during that launch campaign. And so we'll see them go through those final operations there at the pad, the wet dress rehearsal, of course, the tanking of the rocket, making sure that teams are familiarized once again with the flow of loading the vehicle with liquid oxygen and liquid hydrogen. And then they'll get into their launch campaign with a liftoff currently planned for no earlier than February 5th, as we also just learned officially yesterday. So today, what I'm looking forward to hearing is, hearing directly from these 4 astronauts, 3 NASA astronauts, 1 Canadian Space Agency astronaut, about, how tangible this is becoming for them, what the final months of training are looking like now that there's a more refined launch date that they are targeting, and what's going to be on their docket. Sounds like we're hearing a call over the nets. Let's listen for a second.
Well, it sounds like exciting times ahead. I know you need to get off and get ready for that. So thank you for your commentary this morning. And I'll take the audience through the remainder of the mission.
Appreciate you taking the baton, Stephen. And for our viewers, you're in very good and capable hands. So hope you stick around for the next about hour and 15 minutes as we've got some good videos to show with you. Obviously, the mission still progresses, and so we've got a lot more to touch on, including look back at the liftoff itself, which we'll be getting into flow very shortly. So thanks for sticking with us, and be sure to both subscribe to the YouTube channel here, follow us on social media, as I'll have updates throughout the day, throughout the course of our conversations with the astronauts coming up here in the latter part of the morning and throughout the afternoon. Also looking forward to talking with some of the flight directors and seeing the Mission Control Center, which following Orion's separation from the interim cryogenic propulsion stage, the upper stage of the SLS rocket, that's when things will hand over to JSC from KSC and the mission will get underway. Obviously, some very notable, exciting points of operation coming up within the first day of launch. Teams will do a full checkout of the Orion spacecraft, make sure all of the life support systems are working as expected, that there are no show-stopping technical issues with the vehicle. And that includes some, big things that you might think of, like that all the engines and thrusters are working as expected. They'll do a proximity operation with the ICPS, and also some things that you might not think of, but are very critically important when you're talking about a 10-day mission for this crew. Things like making sure that the toilet is in full working order and that there aren't any things like that that would be potentially showstoppers and cause them to pivot the mission. There are a number of different abort scenarios, which we'll be talking more about as we get closer to launch. But in a super off-nominal scenario, for example, if they feel like they are just not in a position to do the translunar injection burn, the TLI burn, if they have not gotten into the highly elliptical orbit, they can do a mission in low Earth orbit and run Orion through its paces with crew on board. They would get quite a bit of good data from that. Obviously, the moon objectives would be lost in that scenario, and that is, of course, very much not the operational plan, but they are going through all the various contingencies, both with the flight director team, with the crew, and all of the ground support as well. So,
Okay, so those are the announcers at Spaceflight Now. They're talking about the Artemis mission, which is going to send a spacecraft around the moon in February. Super exciting. We have been watching the launch of NASA's IMAP mission. IMAP stands for Interstellar Mapping and Acceleration Probe. They also launched the Space Weather Follow-on, Lagrange 1 mission, and the Carruthers Geocorona Observatory mission. I want to thank everyone who joined us here this morning, and I want to thank my co-hosts, David Allian and Greg Diesel-Walk. Thank you, guys. We are EarthSky. We hope you will subscribe, like, and share. We'll be back this afternoon around midday in North America with an interview with Michael Martin, who is on YouTube as Late Night Astronomy. He's going to be talking to us about how you can get started in astronomy and whether you need equipment and what equipment you might need. So that'll be at 17:15 UTC or 12:15 Central Time today. Hope you'll join us then. Thanks so much for joining us. One Earth, one sky, EarthSky.
See, folks.